Hello and welcome to today's webinar. My name is Susan Villegas and I'm the Training Development Coordinator for Now Foods. And as such, I bring you these webinars on the third Thursday of each month. So welcome. So let's get on with today's presentation, which will focus on the different forms of folate and the benefits of Quatrefolic, a patented form of methylfolate that has demonstrated bioavailability superior to that of folate from dietary sources. Our guest speaker for today's presentation is Lorena Carboni. She is the Scientific Communication Specialist for Gnosis by Lesaffre, and Lorraine specializes in scientific and clinical aspects of natural ingredients with particular focus on the carbon metabolites, including folate, which of course is the focus of today's presentation, S-adenosylmethionine, which you may know better as SAMe, and glutathione. Lorena received her master's degree in pharmaceutical chemistry and technology at the University of Camerino in Italy, the Department of Pharmacology, and she has over 20 years of knowledge and experience in the nutraceutical and pharmaceutical industries. And over the course of her career, she has carried out many specific educational projects and publications through collaboration with many universities and academic panels of experts. She currently works with independent and freelance editors and bloggers for scientific-focused publications in web portals and nutraceutical magazines. So with that, please join me in welcoming all the way from Milan, Italy, Lorena Carboni.
Thank you, everyone, to join us in this webinar. I'm very happy to present to you today the role of folate in nutritional health, specifically the role of Quatrefolic, the innovative folate, on our health. Together, we will see some information related to folate, so the folate word, which kind of folate forms are present in the world, and how Quatrefolic can help our health, the role of Mthfr polymorphism, the quatrefolic health benefits, specifically in pregnancy and fertility, and finally, a quatrefolic overview related to the comparison with the other salts present in the market. Folate is a water-soluble B vitamins that is naturally present in foods or added to other available dietary supplements. The role of folate in human health is extremely important. It is a vitamin, so it is essential, specifically in cell division and in DNA synthesis. According to that, it is involved in human growth and development. Humans need really to maintain an adequate dietary intake during all stages of their life. So not only in pregnancy and lactation, where we could think the importance of folate is quite widely known, but also in infant and children and the elderly, and in specific situations like, for example, when the life can impair the availability of folate. Why sometimes food is not enough? Folate are contained in foods, but unfortunately are unstable and susceptible to oxidation. They could lose their activity due to some different reasons. For example, the bioavailability range of folate in general is between 25 and 50%, depending on the kind of food. We used to maintain vegetables at room temperature, and even if we try to maintain their contents with storage, they may lose up to 70% of their folate activities within 3 days. Finally, we used to cook the vegetables in water, and this can increase the loss to 95%. So even if it's widely present, the vitamin B9, so the folate in vegetables like in broccoli, leafy greens, avocado, papaya, and so on, beans, peas, and lentils, at the end, during our life, in our diet habits, the quantity of folate that we may introduce is not enough. And so it is required, especially when we have specific needs, like in pregnancy, like in lactation. I repeat, during stressful, for example, time, we need to increase the level of folate through, for example, supplementation. Folate is extremely important in terms of supplementation because not all people have the right level just using folic acid. Folic acid is, first of all, a main hand ingredient. So it is a synthetic substance. It's not present in foods, and it was simply synthesized by the man in order to create a vitamin that could replace the folate present in foods. Before folic acid can be utilized by the body, since it is not biologically available in the body, must be converted to the reduced folate, that is the active form of folate. During this transformation, we have different enzymes that undergoes this modification, this transformation, and one in particular is extremely important. It is named Methylene Tetrahydrofolate Reductase, and it is today one of the most studied enzyme variants. As you can see, today, in the last 5 years, we can count more than 5,000 different publications on this topic. So the scientific community is really wondering about the impact that this polymorphism can have on human health. For women especially, this deficiency can cause some important health issues that we will see together in the next slide. So what is the main message that we would like to pass to you is that not the 100% of the people can take advantage from folic acid, from taking folate through this kind of substance. Which kind of folate are present in the nature, in the world? We could divide this family in two major parts. Folates, general terms, that refers to structurally related compounds, generally polyglutamate forms that are present in the vegetable. They must be hydrolyzed, so it means that also food folates needs to be transformed in our body in order to be able to be absorbed and to be utilized. And unfortunately, as so before, they are unstable during food processing and storage. The other part is made up of folic acid, so synthetic molecule, oxidated form. It was first synthesized in 1945. Is more stable than natural folate because it is oxidated form, so less sensitive to environmental factors. But unfortunately, folate in the form of folic acid is not active, needs to be metabolized. According to its more stability, it is normally added in supplements and fortified foods. But what happens into our body? What is really the biologically active form? Which is the folate that enter the biochemical pathways that support our health? This kind of form is finally the 5-methyl tetrahydrofolate, generally named also 6S, that represent the three-dimensional shape of this molecule. The 6S represent the stereoisomer that is active in our body. We know that this kind of form of folate that is the same of quatrefolic, that is the active part of quatrefolic effective. It is really the biologically active form because if we take in consideration different studies, different analyses carried out on people, but also in newborn, we could say for sure that this kind of form is the most present in the blood and represent a quantity ranging from 80 to 90% of the total folate. Especially both in mothers and in newborns, this concentration is extremely high. And this can provide us the proof that this kind of molecule is really the folate that our body needs to carry out its activities. But what about the metabolism? So we saw together that folates, in terms of food folates and folic acid, need to be transformed, and the active form is 5-methyl tetrahydrofolate. If you see this nice schema, you can see immediately that folic acid needs 4 different steps in order to be transformed in 5-methyl tetrahydrofolate, so the active form. The same happens with less steps for dietary folates. Quatrefolic has the advantage to be immediately effective and active because it doesn't need to be transformed in each of these steps. The polymorphism and the enzyme related to the polymorphism works exactly in the last part of the metabolism of both folic acid and dietary folate. So it means that both of these forms must be transformed by this enzyme before to be active in our body. But what is the Mthfr polymorphism? It is interesting to know that humans and chimpanzees share about 99% of their DNA sequences. This is amazing if we think that really we are close, but not so far, so far close. In the meantime, we can say that human DNA differ only for 0.5% of the sequences among them. Within 15 millions of nucleotides that compose the DNA. In our body, the genetic code is like a music. The music is made up of different instruments that create the melody, and each instrument does its part. If just one note is not rightly played, we cannot find this very, very point form modification because we are hearing the melody, and just a very, very sensitive ear can really appreciate that maybe there were a mistake. So the polymorphism could be described in the same way. The DNA is like our melody, is a structured information made up of different bases, nucleotide bases that compose the DNA structures. If in these DNA structures there is just one difference, just one error and mistake, we cannot appreciate really a strong modification, but could be that a very, very small, in a very, very small place, there could be something that doesn't work in the right way. And this is the case of polymorphism. Polymorphism is just a point for modification of one base that change the structure of an enzyme, and so practically this enzyme is not able to have the same shape, the same three-dimensional shape in the space, and so does not work properly like the right one. Today, for just this kind of polymorphism, so for the methylene tetrahydrofolate reductase, we can count different polymorphism, but the most studies are two. The first one is named 677CC, and could be present in heterozygous or homozygous form. That means that could be present just in one chromosome or in both chromosomes. Clearly, if it is present just in one, it means that more or less half part of the copies of the enzyme are correct and the other part are with the polymorphism. If the polymorphism is present in both chromosomes, it means that all copies of this enzyme has this modified shape, and so it's not perfectly able to carry out its action. The other important polymorphism that is quite studied is the 1298AA, and also in this case we can find heterozygous and homozygous form. But what happens if we have just one copy or two copy, and if we have just one polymorphism or both? In this table, we can appreciate the modification of the enzyme activities, so how the enzyme activities could change during the transformation of folate. If we don't have polymorphism, we have 100% of activities, but if we have just one polymorphism, we can reach 66% of enzyme activities, and going to 25 in the case of homozygous polymorphism. This can give us a strong vision, strong overview about what could be the risk for these people that can have this polymorphism. But how this polymorphism is prevalent in the population? We know today that 10–15% of many Europeans, Asians, and North American people has homozygous variants, that it is higher in Hispanics population with 20% of the prevalence, and lower in Africans and African Americans and Native Americans. This is due to the evolution that this kind of population had during the history, and also according to the availability of folate sources in terms of vegetables in the specific areas. Today, clearly, since this population are mixed in the different parts of the world, we can think that no countries are without polymorphism, and this could really impact the efficacy of our folate supplementation. What happens where we have a polymorphism? We have reduced enzyme activities because there is also unstable enzymatic activity, and this could open to hyperhomocysteinemia, that is extremely known as an important factor for disease. It is also a risk factor for multifactorial disease, and finally, this phenotype is influenced by non-genetic factors like nutrition, drug, and age. So what is the quadripholic health benefit according to this information that I described to you? So what about folate and its benefit? Folate, after the transformation, folate in the active form has a 5-methyl tetrahydrofolate, regardless if it is determined by folic acid, food folate transformation, or it derives from 5-methyl tetrahydrofolate supplementation, like in the case of quatrefolic, enters the one-carbon metabolism. What is a one-carbon metabolism? It's one of the most important pathways present in every cell of our body, that is responsible to a lot of pathways, a lot of production of substances, like, for example, proteins, lipids, neurotransmitters, and amino acids. And this happens due to the production of S-adenosylmethionine, that is the most important methyl donor that our body has, and these methyl groups are donated by this methylation cycle that starts with the methylfolate and in participation with vitamin B12. Folate application is extremely consolidated, both in the US but also in Europe, where the European Food and Safety Authority has issued some claims, specific claims and approved claims for folate. In this slide, we can see that the most important are related to women planning pregnancy, to pregnant women, to breastfeeding women, and finally also in infant children and adults where there is a folate deficiency. The EFSA is a very severe regulatory authorities and works more on food than dietary supplements, but can give us the idea of how folate contributes really to our health. So for sure contributes to normal physiological function, to immune system, to the reduction of tiredness and fatigue, has a role in the process of cell division, so mainly pregnancy and in the growth of embryo and fetal development, contributes to maternal tissue growth during pregnancy, contributes to normal amino acid synthesis, to blood formation, and finally to homocysteine metabolism. What about the quadriphonic use? So we saw together the role of folate, the availability of folate in foods, how is important to have active form of folate, how this active form of folate could be impaired by the polymorphism of a specific enzyme, and how this can decrease the level of folate available. So at the end, quadripholic, since it is already the biologically active form and the physiological form that we can find in the blood, can really help in different situations, like for example pregnancy. Folate deficiency in this case is causally related to neural tube defect, another birth defect. We know that women that plan pregnancy has to take folate 3 months before and 3 months later at least in order to cover the most delicate time of pregnancy. We need to guarantee the right folate levels in this kind of time, because folate acts as a cofactor for enzyme involved in the DNA and RNA biosynthesis that are responsible for the right growth of the embryo and of the fetus. Folate requirements increase dramatically during this period because we have to take in consideration that we don't need just folate for the embryo growth, but also for the women. And finally, we can have the impairment of carbon metabolism due to, for example, sometimes increased homocysteine level that could be a specific risk factor for recurrent embryolysis in early pregnancy. Folate is also able to normalize the level of homocysteine and so can represent a factor to protect more effectively the pregnancy. Also in fertility, quatrefolic could be extremely helpful. Level of folate and homocysteine status are critical factor in early stage of human reproduction. This means also, for example, during the development of sexual cells. Disturbance in folate metabolism can clearly negatively affect fertility in both women and men. So what are the main factors? For sure, the low folate, often linked with Mthfr polymorphism, and finally the potential increase of homocysteine due to the low folate present in our blood. So optimal folate is the key in order to normalize and to sustain rightly the fertility. Preconceptional folate supplementation has also been linked to beneficial reproductive outcomes in both natural pregnancies and those after assisted reproductive technology. We know because there are today different studies reporting this effect, but also because we have a specific one that evaluated the quatrefolic treatment, especially 800 microgram day, versus folic acid in couples seeking to get pregnant with Mthfr polymorphism. These studies takes into account 33 couples with at least one partner with Mthfr polymorphism. Most of the women previously treated unsuccessfully with high doses of folic acid were able to have a pregnancy. Specifically, the results show 13 spontaneous pregnancies and 13 pregnancies after assisted reproductive technologies with a pregnancy rate of 86.7. Here we can see the prevalence of the polymorphism in this kind of study. Wild type is normal type without any kind of problems, no polymorphism. Heterozygous account for 48% and homozygous accounts for 17%. But what about homocysteine? Going inside the specific mechanism that raises the homocysteine level into our blood, we can see in this slide how this is the part related to the transformation of folic acid in 5-methyl tetrahydrofolate. The part on the right is related to one-carbon metabolism. We can see that when homocysteine is produced during the one-carbon metabolism, it is remethylated through methionine when 5-methyl tetrahydrofolate enter the cycle in co-participation with vitamin B12. If we have low folate, clearly the homocysteine cannot be retransformed in methionine. And even if the body has different other mechanism, for example, homocysteine it is transformed also through vitamin B6 in cysteine and later in glutathione, or there is another mechanism that adapt the transformation of homocysteine to methionine. Low folate impacts severely on the homocysteine accumulation. For that, any kind of situation that can impair the folate availability, like for example, polymorphism, but not only, general factors like drugs utilization, alcohol, smoking, aging, or specific pathologies can lead to an increase of plasma homocysteine. What about quatrefolic? Quatrefolic, since it is the biologically active form of folate, was tested versus folic acid with a suggested daily dose of 400 microgram versus a high level of folic acid, 5 milligram, that is generally suggested by doctors and practitioners when people has a hyperhomocysteinemia, so higher level than daily required for folate. In these interesting clinical trials, the quatrefolic was more able to normalize the level of homocysteine than folic acid. Normalization is in important terms because it means that we don't need to decrease the homocysteine, but we need to maintain in the normal level that in humans is considered 10 micromole per liter. In this kind of subjects, the homocysteine was mild. They had mild hyperhomocysteinemia, and so quatrefolic was able to report in a short time to 10 micromole liters. So what about the quadrifolic advantages versus other form of folate? First of all, quatrefolic is the active form of folate, is the 6S-5-methyltetrahydrofolate, just in the form of glucosamine salt. All the natural folates ingested are turned into 5-methyltetrahydrofolate, so the advantages of quatrefolic is to provide already the active form without the need to be metabolized. Another important thing is that 5-methyltetrahydrofolate is the only folate crossing the blood-brain barrier, and it is also the essential form in which folate occur and are stored in human body. Quatrefolic was tested versus the other salt form, the calcium salt, in order to highlight the advantages in terms of pharmacokinetic. In particular, a preclinical trials was carried out, and it was tested not only the calcium salt but also the folic acid in a single dose in rats. The peak plasma level of quatrefolic was about 20% higher than the calcium salt. Another test was carried out on humans, just comparing calcium salt with quatrefolic. In this case, quatrefolic demonstrated better bioavailability, around 10% more than the calcium salt. Bioavailability, it is important because give us an idea about how this kind of ingredients can be effective in our body. But what more about the glucosamine salt? Glucosamine choice was extremely important in the development of quatrefolic because it is, first of all, a substance that give the salt, so the quatrefolic, a very high solubility in water. We know very well that the solubility in water increase the availability of 5-methyltetrahydrofolate in the gut, in the gastrointestinal tract, in order to be absorbed. So clearly, the time that intercourse between the ingestion of a form of folate in terms of calcium salt, of the glucosamine salt, change a little bit also the availability of the compound into our body. So this kind of advantages can also support the increased bioavailability of quatrefolic versus calcium salt. I thank you very much for your attention. I hope that the word of folate is today more clear for you, and especially the role, the active role, the key role that the 5-methyltetrahydrofolate in the form of quatrefolic can have in our health, and especially in pregnancy and in fertility. Thank you very much.
And thank you, Lorena. Great information. And one of the things that I was going to ask, which you answered very nicely, was about polymorphism, because I wasn't sure what that was, but I really like how you made that comparison between the genetic code and the music notes in a symphony. That really gave me a good visual and a good idea of what that truly is, that polymorphism. So that was great. That was a great explanation.
Thank you, Sue. Yes, it is for us extremely important to explain in easy way a concept, a biological concept that could be not very easy to understand. So the melody is really the key to understand how the polymorphism can change our efficacy to transform folate.
Yeah, and you're right. It is a hard concept to kind of understand, and I might even have to go back and look at this again and look at your charts, to really grasp how this is converted in the body, but it was very, very good. And is it recent? I know we hear a lot in the United States about the importance of folic acid for pregnancy. And I didn't realize that it was even before pregnancy. I didn't realize that how important it was then. Is the research recent, or how long has the research been going on the folate?
Okay, not recent, Sue. Honestly, as I explained at the beginning, the possibilities that we are deficient in folate are not rare. When a woman decides to have a baby, she doesn't know her level of folate. And when she discovers that she's waiting a baby, 2 months passes at least. So it means that in this window of time, the level of folate that impacts severely on the development of the embryo is extremely at risk. If the woman doesn't have the right level of folate, neural tube defect can be present with very strong effect on the fetal growth. And so it is important that women reach right level of folate before they decide to have a baby. Folate needs months to reach the right level if there were a deficiency. So according to that, generally it is required to consume folate at least 3 months before in order to cover this potential deficiency, and later to cover the first 3 months where the most important structure of the brain of the baby will be developed. So for that, it is extremely important.
Okay, and we know it must be important because in the United States we don't allow many Food and Drug Administration claims, and folic acid is one of them. So it must be very, very important.
Let me also explain. Maybe it could be important also for our audience to say that the fortification of folic acid depends by this situation. I mean that with the fortification, the idea of the health authorities was like to cover all population, and so to be sure that also the persons, also the women that do not decide to have a baby, or the women that do not have the right level of folate, are not exposed to folate deficiency, and so are not exposed to the potential neural tube defects. Honestly, we have a lot of situations where folate it is required, and so we could have this deficiency. So we need to supplement the active form of folate in order to give our body what the body requires, not some things that could be not rightly metabolized, that needs different enzymes. So 5-methyl tetrahydrofolate quadrifolic represent really the key to answer to a body needs.
And like so many of our nutrients that we do need, is now being depleted because of our soils, in the soils in which the foods are grown, and we're just not getting those nutrients anymore that we need. So, and
Absolutely.
when you speak of aging, as I continue to age, my ears always perk up. So, well, thank you, Lorena, for an excellent presentation. I appreciate all of the research and the great information, and I hope you'll join us again someday soon.
Thank you very much, Sue. I appreciate the space that I had, and I really thank you for the attention, all everyone that assisted to this presentation. Thank you again.
Bye-bye.
Bye-bye.
All right, I'm going to stop the recording now.
Sue, what was